Hello learners, in this lecture we will see how this experiment has to be done practically in the site. So this is how we have to follow. Now as of now we are concentrating on the fine aggregate. So coming to the objective, to determine the finest modulus of a fine aggregate and has classified based on Indian standard 3831970. What all apparatus is required for us? We require the test sieves conforming to Indian standards 4601962 specification. Then since we are doing it for the fine aggregate, and that is the reason we require 4.75, we require 2.36 mm sieve, we require 1.18, we require 600 micron, 300, 150. You require a balance for that, weighing balance. You require a gauging trowel, you require a stopwatch, and etc. Right now, how do you remember this? So to remember this, it's very simple. Remember 4.75. This easily we can remember, and half of 4.75 is going to be 2.36. So half of 3.3, half of 2.36 is going to be 1.18, and half of 1.18 it's going to be, we'll try to see that how much it comes out to be. Yeah, it comes out to be 600 micron. Half of 600 micron comes out to be 300, and half of 300 comes out to be 150. So this is how we need to remember this, the size of the sieve. Similarly for the coarse aggregate, I'll be explaining the same way. Now coming to the test procedure, the sample shall be brought to the air dry condition before weighing and the sieving. That means whatever sample you're using, the fine aggregate, we should try to take it in a dry condition so that there is no moisture in the sand. The second is measure the sample on the weighing balance. What should be the weight that you have to take? We'll take 100 grams of that, 1000 grams of that, that is 1 kg. So we are going to weigh that. Arrange the sieve in the descending order of a size from larger sieve on the top. That means 4.75 mm sieve is going to be at the top. This is my 4.75, followed by 2.36, followed by 1.18, and so on. So put the sample in the upper sieve, that is the whatever sample 1000 gram of uh, sand what I'm going to take, that I have to put it on 4.75 mm sieve, because that will be on the top, and shake manually or with a sieve shaker for 10 minutes. Material shall not be forced to the sieve by hand pressure, right? You should not put a pressure on the sand so that they are going to pass. Only by sieving it has to pass, and no external force has to be applied. So once these things are clear, next what we are supposed to do, this is how it's going to look. It's a sieve shaking machine what we have, and these other sieves what I arranged. Let us say I'm keeping 4.36 here, then 2.36, 1.18, 600, 300, 150, one. Yeah, then the finally you are going to keep a pan there, right? So this is how it has to be arranged. Yeah. Next, after 10 minutes, because you are going to sieve it for 10 minutes, we'll switch on the machine. You can see there is a button here. You have to switch it on for 10 minutes. And that is why the stopwatch is taken. Else you can even try to measure it with the help of your normal watch. Yeah. So after 10 minutes, stop the shaker and separate the sieve from the apparatus. Measure the weight of the particles retained in the each sieve and note them in the table. Like I mentioned, if something is retained on 4.75, weigh it how much it is retained. If something is retained on 2.36, weigh that on weighing balance and write it here. For 1.18, weigh it and write it here. So finally, calculate the percentage of the weight that is retained on the each sieve. So whatever I explained in the previous lecture, the same thing that we need to do it here. Remark if there is anything you have to do the remark, else it is not required. Finally, coming to the finest modulus, total cumulative percentage of the weight retained, that is total cumulative of the percentage weight retained, you have to divide it by 100, and whatever answer you are going to get, let us say you got an answer, as let us say 1.96. You got an answer as 1.96 is the finest modulus. So now start to measure from here. That is 1, 2, 3, 4, and 5. So this let us say instead of 1.96, let us say I got answer as 3.96. Okay, so this 3.96 is going to lie in between this, that is 3 is here, 4 is here. That means my particle size will lie in between 1.18 to 600 micron. So this is the importance of the fineness modulus. Similarly, the same experiment whatever we have done for the fine aggregate, the same has to be done for the coarse aggregate. In the coarse aggregate, what is going to change? Here 80 mm will be used, 40 mm, 20 mm, 10, and 4.75. Again the same thing. Half of 80 is 40, half of 40 is 20, half of 20 is 10, and here it is almost 4.75. And the other things remains the same. Procedure also remains the same. There is no change in the procedure. And these are the sieve sizes what we have, like 80, then we have 40, then we have 20, and this is 4.75, and let us say this is 10, and so on. This is how it has to be arranged. The bigger one will be at the top and followed by the lower one, right? That's it. And again, the same thing what you can see there, the same table you have to make it here. Again, the finest models you are going to calculate total cumulative divide by 100. Whatever answer you are going to get, you are going to write it here, that this is the finest modulus of that, right? Yeah, I hope the basic understanding is clear. We have covered the finest modulus of the fine aggregate and also the coarse aggregate. So in the next lecture, we'll try to see few other test how it has to be done on the aggregates. So we'll see you back in the next lecture. Thank you.